Seems like a lot doing 2 sections in one day. The good news is we already really did section 4.2. We really did that on Monday. So in section 4.2, they have things like simplify 3x plus 2 minus 5x plus 7. How do you simplify something like that? What was it? You combine the like terms. And what are your like terms?
3x.
All right, you've got a 3x and you've got a minus 5x. So you put those together. What do you get when you put together a 3x and a minus 5x?
Negative 2x.
Negative 2x. And then what else do you have for like terms?
2 and 7.
Your numbers, 2 and 7. 2 and 7 make?
9.
9. So our answer would be minus 2x plus 9. What if I gave you 3 times 4x minus 1 plus 2 times x plus 5? Distribute. In fact, you have to distribute twice, don't you? Because there's 2 sets of parentheses with a number outside. Okay, so we distribute. And what do you get when you distribute? 12x minus 3 plus 2x plus 10. Okay, very good. Once again, we look for our like terms. We combine our like terms. What do we get? 14x plus 7 minus 3 plus 10 is 7. Very good. Questions on that? What if I decide I'm in a bad mood and I put some fractions in there on you? How about
Burn it. I think you should say in a good mood.
1/2 x minus 1/3 x? How do you take 1/2 x minus 1/3 x?
Put the x over 1.
Okay, you could think of the x over 1. That's true.
Oh, common denominator.
You're subtracting things. To add or subtract fractions, you have to have a common denominator. Okay. What's my common denominator? 6. To turn a 2 into a 6, I had to multiply by 3. So this one is going to be 3 over 6 x. And the other one's going to be 2 over 6 x. So now we subtract. 3/6 x minus 2/6 x is 1/6 x. So nothing new. In order to add or subtract fractions, you got to have common denominators. Just the way it is. And maybe I might do this too. I might say, how about 1/3? Oh, let's make it 2/3. Make it interesting. 2/3 times 6x minus 9. How do you take 2/3 and multiply it by 6x minus 9? Use your calculator. Your calculator has a trouble with that little letter x right in there.
I have a graphing calculator, so
Your calculator still, you
I'm
can,
lying, I don't.
even if you have a graphing calculator, if I type this into my graphing calculator, it won't give me the answer.
Is there any calculator
Can't you
to put
just
variables
do-
in and do it with?
Yes, there are calculators that will do it.
Yeah, can't you just do, and then just make the x be there?
You multiply, you distribute just like you always do.
Okay.
So you're going to take 2/3
Times it by 6.
and times it by 6. How do you take 2/3 and multiply by 6?
I would turn it into a decimal, try to turn it into
Put a
something
1 on your
else.
x.
No, we're never going to turn things into decimals because 2/3 as a decimal is 0.66666 going forever. We don't want to do that. So we're going to take 2/3 times 6 over 1. That's what we're going to do. How would you take 2/3 and multiply by 6 over 1?
First you can cross multiply the 3.
Well, not cross multiply, but cross reduce. 6 and 3 reduce to be a 1 and a 2. So 2/3 times 6 turns out to be the number 4. So back up here, we're going to have 4x minus, and then I do the exact same thing. I take the 2/3 and I multiply it by 9. 2/3 times 9 over 1. Exact same thing. I can cross reduce, right?
Yeah.
1 and 3. And I end up with 6. So that's what you're going to do. Don't let those fractions freak you out. You're just going to multiply the way you'd always multiply. Write down the x where you need the x. Questions on that? All right, well, that was 4.2. Like I said, we did a lot of that the other day, back when we covered 4.1. Section 4.3. We're going to start to learn how to solve linear equations. Now, the word linear, to a math person, what does linear mean?
Line.
When you graph, you get a line. Okay, but when we deal with linear equations, when you say when you graph, you get a line, usually that has an x and a y. We're going to be dealing with equations that only have x's in them. So to a math person, what linear means all variables have power 1. Example. (2x plus 5 equals 9). We would say that is a linear equation. Why is that a linear equation? There's only one variable, and what's the power on that variable? It's a 1. This equation, however, would not be a linear equation. How come that was not a linear equation?
Because it's squared.
It's got an x with a power of 2. Other things that would not be linear would be if I put a square root in there. That would not be linear. Square roots mess things up. The other thing we can't do, we can have fractions, but we can't have x's on bottom. I could have a fraction like 1/2, but I cannot have a fraction with a 2 over x. So all these things would be called not linear. And later on in this course, later on in the semester, we will talk about how to solve some of those equations. Not all of them, but some of them. But for today, we're going to worry about linear equations, things where the power is 1. To solve linear equations, there are 2 rules that you use. What are the 2 rules? Anybody know? And what do you do to get x by itself?
I figured it was balancing.
You have to do the same thing on one side and the other, right?
And what things can you do to each side?
Addition, subtraction, multiplication, division.
All right, so the 2 rules are: 1, you can add or subtract anything to both sides. And rule number 2, you can multiply and divide both sides by any number except the one bad number, and the one bad number is 0. How come you can't multiply both sides by 0? When you multiply by 0, you get 0. You would have 0 equals 0. That doesn't do you any good, does it? How come you can't divide both sides by 0?
Because it's either going to be undefined or...
Not either. Always. It will always be undefined. Can you ever divide by 0? No. So you can never divide by 0. You would have undefined. Okay, so in this section, we're mostly going to have rather simple equations. We might have something like, well, we'll get to that one in a minute. X minus 2 equals 5. What's the answer to that equation? 7. Why is 7 the right answer?
You add the 2.
Or you could say 7 minus 2 gives you 5. But you're right, the way we solve is we add 2 to both sides, and our answer would be x equals 7. See, I told you they were going to be rather simple. How about if I gave you x plus 4 equals -6? -10, and how'd you get -10?
Avoid 4.
To get rid of the add 4, the opposite of add 4 is subtract 4. So you do a -4, you do it on both sides, and then you combine, x is -10. Okay. How about if I gave you 3x is 12? 4. Why 4? Why do you divide this time?
It's multiplication.
Because it's multiply. Here we did add because add was the opposite of subtract. Here we did subtract because subtract was the opposite of add. Here we have multiply. The opposite of multiply is divide. So we divide both sides by 3. And our answer is x is 4. What if I gave you x over 6 equals -5?
Multiply by 6.
Why do you multiply by 6?
Because you're doing the opposite of division.
Because you're doing the opposite of division. The opposite of division is multiply. So you're absolutely right. To get rid of a division, we do a multiply. These cancel out, and you get x's -30. Okay, how about this one I had written up here a few minutes ago? 2x plus 5 equals 9. Usually we do the adding and subtracting first. That's absolutely right. So we see that we have a plus 5. We get rid of the plus 5. We do a plus 5 by doing a minus 5. 2x is 4. And then you divide because that's a multiply. To get rid of a multiply, you do a divide. X is 2. Questions on that one?
You say usually.
I say usually because you don't have to do it in that order. If you want to, that's a very good question. 2x plus 5 equals 9. If you want to, you can actually do the dividing first. So I'm going to do the dividing first. What would I divide by? 2. And here's why we don't do it first. What happens when I divide by 2?
4.5.
No, we don't use decimals in this class.
4.5.
X equals, or I'm sorry, x plus 5 halves equals 9 halves.
Do you have to put the 2 under 5? Do you have to divide the 5, or can you like subtract 5?
If you divide, you have to divide everywhere.
Okay.
This is why we usually don't divide first.
Okay.
How come we usually don't divide first?
And that's when you do 5.
Because it makes fractions. Do we want fractions?
No.
No. Well, to solve though, now we would subtract 5 halves. So x is, what's 9 halves minus 5 halves? 4 halves, which is a fancy way of saying 2. Do you get the same answer? Yeah, but you really don't want to give yourself fractions if you don't have to, right? So that's why we usually do the adding and subtracting first, because then we don't have to deal with the fractions, and we like that better. Questions on that? Well, now sometimes you can avoid fractions, though, because sometimes you have things like 3 halves x equals 9. Multiply by? Why do you multiply by 2/3?
Do what you do on one side.
The other across. They would cancel each other out.
Right. The reason you want to use 2/3 on the left-hand side, what's that 2/3 going to do to that 3 halves? The 3's reduce, the 2's reduce, and you're left with x. The x is still there, right? The x doesn't disappear. Of course, if I'm going to do 2/3 on the left-hand side, I have to do 2/3 on the right-hand side. So again, don't let the fractions freak you out. The fractions aren't that bad. To get rid of a multiply by 3 halves, you do a multiply by 2/3. You just flip it over. Answer is x equals 6, because again, we think of this over 1, we reduce, x is 6. Or you might end up with something like x minus 2/5 equals 3/10. Again, sometimes you have fractions, there's nothing you can do about it. How do you get the x all by itself? You have to add 2/5. So x is, how much is 3/10 plus 2/5? 7/10. Why 7/10? You've got to have a common denominator. If you are adding fractions, you always have to have a common denominator. What's my common denominator? 10. So that one is already 3/10. That one I multiply top and bottom by 2 to make it 4/10. 3/10 and 4/10 is 7/10. So x would be 7/10. Questions on that?